The second part of the definition is pay-per-use. Now, pay-per-use has sort of two meanings here. Pay-per-use mainly means that you pay for the amount of cloud capability that you need and no more. Now, there's a variety of ways in which pay-per-use exhibits itself. In the case of software as a service, it exhibits itself in the sense of you pay for the number of users who use it, but you pay for it perpetually. In the case of infrastructure as a service and many other types of services like cloud integration capabilities, cloud databases, and so forth, you actually pay for the actual resources consumed and no more. And that's typically metered in a very frequent manner. It could be metered per hour, it could be metered per month, just depends on the type of service and its common use model. The last part is a self-service way, and this does not mean that you just have a portal on the front end or a web page on the front that says deploy. What it means is that when someone hits deploy, that the cloud service is actually provisioned automatically within 5 to 15 minutes. If that isn't happening, that means that hitting of the button deploy goes to his help desk and somebody manually has to configure the service. If that's happening, you're not going to achieve cloud economics, and that's not a cloud service. So try to use this as a decoder ring to understanding what really is cloud and what is simply a cloud-washed traditional solution. Now, the key thing to understand about cloud is because we're talking about standardized services that can be used over and over and over across multiple customers, abstraction is a very key part of cloud computing. If you take a look at the depth of knowledge of the consumer of the cloud service, there's wide ranges here. There's people who really can know more than customize a web page, who could maybe answer some questions in a Q&A about what the environment should look like and how it should be set up. As you get farther down in skill sets, you get people who can actually code. Maybe they can only code in scripting. Then as you get further down, they can actually write a full application in .NET or Java. And when you get way down the bottom, you get people who not only can code an application, but they can deploy an operating system, patch it, manage it, monitor it, configure the middleware, and all they really need is a virtual machine. When you look at cloud solutions that are out there, they set an abstraction point that defines the service and defines who, based on their skill set, is the target audience. So when you look at the cloud solutions that are out there, I know all of you have heard about the SPI models, SaaS, platform as a service, and infrastructure as a service. Those are points of abstraction that define who can consume the service based on their skill set. So if you look at infrastructure as a service like Amazon Web Services EC2, that is very much for the low end here. It's for the people at the very bottom who have very deep skills, and you can just give them a raw virtual machine, they can put anything inside of that. That means that whoever puts stuff in that virtual machine is responsible for managing and operating everything from the VM up. When we look at Windows Azure, that is something where you don't get a raw virtual machine, you mostly get an abstraction layer that's at the middleware point. So if you're writing an application in .NET, you get a middleware where a .NET application will run. And that's a really important differentiation because everything below that line is managed by the service. You don't care about what version, what protections are done around the middleware. You don't care about the patching of the operating system. All that's taken care of by the platform as a service. And so when you get higher up, you get higher levels of abstraction.